Hello everyone, my name is Dalley and today we're going to be talking about the axilla. The axilla is the anatomical space inferior to the glenohumeral joint, superior to the axillary fascia, at the junction of the thorax and the neck. It's pyramidal and has an apex and a base and 4 walls. The apex of the axilla, also known as the cervical axillary canal, is bounded by the first rib, the clavicle, and the superior border of the scapula, and it acts as a passageway for neurovascular structures from the neck to the axilla. The base of the axilla, on the other hand, is formed by the concave skin underneath, also known as the axillary fascia or the armpit. While the anterior border of the axilla is formed by the pectoralis major and pectoralis minor, the posterior wall of the axilla is formed by the scapula, subscapularis, and inferiorly by the teres major and the isthmus dorsi. On the other hand, the medial border is formed by the first 4 ribs and their intercostal muscles and the serratus anterior, while the lateral border of the axilla is formed by the intertubercular groove. There are a few passageways associated with the axilla. On the anterior surface, we have the clavipectoral triangle, which is bounded by the deltoid, the clavicle, and the superior border of the pectoralis major, and it acts as a passageway for the cephalic vein and the medial and the lateral pectoral nerves. Whereas on the posterior surface of the axilla, we have the long head of the triceps and the surgical neck of the humerus, and the teres minor and the teres major, forming 3 anatomical spaces. First, we have the quadrangular space through which the axillary nerve and the posterior circumflex humeral artery pass through. Then we have the triangular axillary space through which the circumflex scapular artery passes through. And last but not least, we have the triangular interval through which the radial nerve and the deep artery of the arm pass through. Hypertrophy of the teres muscles and the triceps would result in the shrinking of these anatomical spaces, which would result obviously to the compression of these neurovascular structures, which would lead to clinical conditions such as the quadrangular space syndrome. The axilla contains very important structures such as the axillary blood and lymphatic vessels, the lymphatic nodes, and the cords and the branches of the brachial plexus, all embedded in the fat matrix of the axilla, and they are mostly vulnerable when the arm is abducted. These neurovascular structures are proximally embedded within the axillary sheath, which is a sleeve-like extension of the cervical fascia. Second, let's move on to the axillary artery. The axillary artery is the continuation of the subclavian artery, and it runs from the first rib until the lateral border of the teres major, where it continues as the brachial artery. The axillary artery can be split into 3 parts, where the second part is the one behind the pectoralis minor. For the first part of the axillary artery, we have the superior thoracic artery, which is highly visible and runs just underneath the subclavius. Whereas from the second part of the axillary artery, we have 2 arteries that pass through. First, the thoracoacromial artery, which is short and thick trunk that splits actually into 4 arteries: the acromial, the pectoral, the clavicular, and the deltoid. And we also have the lateral thoracic artery, which runs along the lateral border of the pectoralis minor. Last but not least, we have the third part of the axillary artery, which conveniently has 3 arteries that branch off. First, we have the subscapularis artery, which is short and actually splits into 2 arteries: the circumflex scapular artery, which wraps around the posterior surface of the scapula, and the thoracodorsal artery, which runs along the lateral border of the scapula. And the last 2 arteries are the anterior and posterior circumflex humeral arteries, which wrap around the humerus, forming an anastomosis. Note that on the posterior surface of the scapula, we have several arteries that anastomose, such as the thoracodorsal artery, the circumflex scapular artery, the dorsal scapular artery, and the intercostal arteries, forming a mesh-like network of blood vessels. Now let's move on to the axillary vein. The axillary vein forms from the union of the basilic and the brachial veins on the lateral border of the teres major. In the axilla, it runs medially with respect to the axillary artery, where the cephalic vein drains into it. And just like for the axillary artery, at the first rib, it turns into the subclavian vein. Now let's move on to the axillary lymph nodes. In the axilla, we have 5 clusters of lymph nodes. We have the apical lymph nodes, the humeral lymph nodes, the pectoral lymph nodes, the subscapular lymph nodes, and the central lymph nodes. The second last thing that we'll be talking about is the brachial plexus. The brachial plexus is a major network of interjoining nerves that pass from the neck to the upper arm. The roots of the brachial plexus are the anterior rami of C5, C6, C7, C8, and T1 nerves. These then unite to form the superior and the middle and the inferior trunks of the brachial plexus, each of which then divides into the anterior and the posterior divisions. These divisions then form the lateral and the posterior and the medial cords of the brachial plexus. These cords then eventually give rise to 5 terminal branches: the muscocutaneous, the median, the ulnar, the radial, and the axillary nerves. We also have branches that rise from within the brachial plexus, namely C5, C6, C7 roots, the superior trunk, and the lateral and the posterior and the medial cords. Injuries to the brachial plexus at different levels would lead to different conditions with different severity, such as Erb's palsy due to injuries to C5, C6, C7 roots, which is very common in childbirth, or Kluwer's palsy, which is due to injuries to C8 and T1 roots. Thanks for making it this far through the video. I hope you found it interesting. Take care, bye bye.